Okay, so this is number 7, and 7 has 3 parts to it, so this is going to be part A. So the original problem reads, a particle travels along a line. Its velocity in meters per second is given by the velocity function equals 3t squared minus 12t. And for A, it says find displacement from t equals 0 and t equals 8. So I changed up the equation and I changed up the times. So we're going to find the displacement from t equals 0 to t equals 5. So in order to get displacement, we have to antiderive our velocity formula. So 2t squared minus 8t. And we could separate this into 2t squared minus 0, 8t. Oops, I forgot my dt's. Put those in there. Okay, so we're going to move the constants outside. So we get 2, 5, 0 of t squared dt minus 8, 5, 0 t dt, and take the derivatives of those. So we'll get 2 times t cubed over 3 from 0 to 5 minus 8 squared over 2 from 5 to 0. So we could simplify this one at least to make it, oops, forgot my t in there. We'll make it 4t squared. Okay, so now we're going to plug these in. So 2 times 5 to the third all over 3 minus, we're going to assume this is 0 because if you plug in 0 cubed, it's 0, minus, we're going to plug in 5, so 4 times 5 squared, and we would subtract, if you plug in 0 in here, we would subtract that normally, but it just equals 0, so we're going to leave it out. So this can change to 2 times 125 over 3 minus 4 times 25, and that can change to over 3 minus 100. So we would get, oh shoot, I don't have a calculator. Okay, so I did this with a calculator, and our equation would come out to negative 16.67 rounded. So even though the displacement is negative, that's okay. That just means it's more towards us than away, if that makes sense. Okay, so for part B of number 7, it says find the distance traveled by the particle, and since we're doing it for our equation, we're going to go from time intervals of 0 to 5. So this is the equation we're working with. So what we're going to do is we're going to take a 2t out to make it 2t times t minus 4. And then we're going to find the zeros. So zeros are going to be at 0 and 4. Then we're going to make a velocity table. Of 0 to 4, and from 4 to our other interval, which was 5. And if we test 1, if we plug 1 back in, we will get less than 0, so this will be going backwards. And if we plug in, let's say, a 4.5, that will be greater than 0, so we'll be going forward. So now we just need to know, we need to put absolute values when we find the antiderivative of that. So antiderivative of 0 to 4 from VT, which we found in that other one, and we just need to put absolute values around it, plus antiderivative of 4 to 5 of v times t to the dt. So we're going to use our other equation, which was okay, so we're just going to find the interval from 0 to 4 for this one. So our original was 2t to the third over 3 minus 4t squared. That's from 0 to 4, plus absolute value of that, 2t cubed over 3 minus 4t squared from 4 to 5. And then you're going to plug in those numbers. So what you're going to get is 2 times 4 to the third over 3 minus 4 times 4 squared, and this is just going to be 0, plus, if we plug in 5 for this, so 2 plus 5 cubed over 3 minus 5 squared, plus, that's going to be a separate parenthesis. And we're doing plus because we want to include everything since it's distance. 2 to the 4 cubed over 3 minus 4 squared, 4 to 4 squared.